Hello students, welcome to the Mobile Robotics Lab. Today we are going to learn how mobile robots move and how they understand their surrounding environment. This is the foundation for all our upcoming experiments. How does a robot work? It follows a simple rule called sense, think, act. Just like human eyes, a robot has ultrasonic and IR sensors. These detect obstacles. The microcontroller, which acts like a brain, processes this information and gives commands to the motors to move in the correct direction. The crucial secret here is sensor fusion and odometry. Instead of relying on just one sensor, the robot combines data from multiple sensors to make accurate decisions. Through odometry, it calculates the rotation of the wheels to precisely estimate its exact location. Come on students, let's build something great.
Hello everyone. We are using mobile robotic, a small project. This is an obstacle detection robot, automation robot. We are using Arduino Uno, motor driver, and Ultrasonic sensor. I will show the demo. Now it is running because there is no obstacle. When the obstacle will come, it will stop. Now we need a component to assemble this. We need a screw box, motors, means DC motors with the gears and the jumper wires, screws and nuts, tire, motor driver, Arduino Uno, and chassis. Now we'll start assembling. You can take a one chassis or both the chassis. I will take the one chassis now. This is a DC gear motor. These are jumper wires for DC gear motors. One for neutral, one for phase. This is for phase and this is for neutral.
Students, a quick but critical terminology correction here. The terms phase and neutral are strictly used for alternating current or AC, like the power in your house. Since we are working with the battery, this is direct current or DC. Therefore, we refer to these connections as positive and negative, or VCC and ground. Using the correct technical terms is the first mark of a good engineer.
Okay. Now this is a one motor driver, one motor DC motor. You must do 4. 1. These are 3 DC motors. These are the same connections, phase and neutral. Now I'm completed the wiring in the DC motors. Let's begin to connect the chassis and the DC motors with the wheels. We need the frames, nut and the bolt. Take the chassis in the hand, put the DC motor from downside, put from here, sorry, here, hold it, Take again one, hold it here, take the nut, take the bolt and connect this like this, and take again one. This is down, again one is hole is there. Take the bolt. This is ready now. Now we will do similarly three motors in the chassis. Now I am done with the motors. Now I will take the wires and put this in hole like this to get the driver, DC driver and the microcontroller, means Arduino Uno. This is first motor, this one. This is second motor, this one. This is third motor, this one. And this is fourth motor, this one. Now I will connect red and red, black and black for a forward and reverse. These are forwards, these also forwards. Now it is done. Now I will check with the battery that it is going forward or reverse. Now I taken a 5000 mAh battery to see the forward or reverse going motor drivers. Motor DC gear motors. Now connecting the tires. Connected. I will take the back. Black color means neutral. I'll put in a port of the neutral. And face to the face. You can see here one is going front and second one is going backward. Now we must do cross connections, means red to black, black to red. I must review again one time. We must see the connections. See the connections. Black to red. And red to black. Now we will see again one time. Now we'll do connections to the battery. Now it is going forward, forward. Now we'll do same connections to these two motors also. We put the tires here and here. See the connections for the battery. These both are going this side and this is going back side. And I will do same connection like this. This tire face, we must go this tire neutral. Like this and this too. Now we'll check with the battery. Now it is going correctly. Now we take motor driver. There is an L298N motor driver.
Let's understand why we need this L298N motor driver module. Why not connect the motors directly to the Arduino? The Arduino's microchip is a brain, not a power supply. It can only safely output about 40 milliamps per pin. A DC gear motor draws hundreds of milliamps. If you wire a motor directly to the Arduino, you will instantly burn out the microcontroller. The driver acts as a heavy-duty digital switch, using the small logic signals from the Arduino to safely deliver high current from the battery to the wheels.
You can see here, there is a output 1, output 2, output 3, output 4. And these are a ground 12 volt plus and 5 volt for a microcontroller, means Arduino Uno. Now you connect to the motor, DC motors. One for output 1, means one motor. Second for output 2, means second motor. Next, and same from this side. Now I'm completed the assembly with the motor driver. Now I'll take the Arduino Uno and I will dump the code.
Provide me and code a C++ program for Arduino to run an obstacle avoidance RC robot. This is a code. Copied. This is Arduino cloud. You have paste it like this. Here is a code. Now you can see here, include a new ping.h means ultrasonic sensor. Ultrasonic sensor pins means trigger pin 9. In Arduino board there is a 9 pin put on there and echo pin on 10. Distance must be 200 meters means 20 centimeters. The motor driver pins means motor driver L298 pin is left motor in line in 4 means port number 4 and same in 5, 6 and 7. The next obstacle means in how much distance we must catch the obstacles, that is 20 centimeter. Then new ping in sensor solar means trigger, echo and max distance, that is here. Pin mode means left motors and right motors output. This is serial dot being means 9600 debugging. The distance of the solar centimeters, means how much you want you can put in here, means 10 or 20 or 30. There is a distance. Then stop the motors, delay 500 means 5 seconds. Then there is a turn left motors means 100,000 means 10 seconds. Delay 100 means 10 seconds, sorry, 1 second. Then there is a motor control functions. There is a move forward, that is first motor means left motor is high and left motor second one is low, and same in right also is high first motor and right motor is low. Then turn right, turn left, stop motors. Turn right and turn right are same, just difference between left and right. And stop motors are all are low, means 0. Now I will upload the code. I will connect the board to my PC like this. Then search the device. We will put the Arduino Uno. Then we will first verify the code. Verified. Then we will upload the code. Now it is saying thank you and okay, means uploading has done. This was a code to upload the Arduino Uno of obstacle detection RC robot.
Just now you have seen how to upload the code. Now we'll see the connections. This is ultrasonic sensor. I will take the jumper wires. These are the jumper wires. There is a 4 pins. There is a 4 pins: trigger, echo, ground, and vin. Now I connected the 4 pins, ground, VCC, trigger, and echo. They are written here, backside. Now take the Arduino Uno, and I will connect the motor driver to Arduino Uno. These are jumper wires. These are some jumper wires. These are a male and these are females. Now I will connect the motor driver to the my Arduino Uno. And this is a jack to connect the motor driver to the main power supply. You have seen before there was a 12 volt and there is a ground. I will connect there only. This red is phase, means 12 volt. And this neutral means ground. And I will take again one wire, male to male, the receiver this. These are male. This will connect 5 volt from the motor driver to microcontroller, means Arduino Uno, and ground also. I connected ground, here it is, and this is for 5 volt to Arduino Uno.
Lab safety warning. When using the 5-volt output from the motor driver to power your Arduino, you must be extremely careful about your main battery supply. The L298N has an onboard 5-volt regulator. If your main battery exceeds 12 volts, you must remove the 5-volt regulator jumper on the board. Supplying higher voltages without removing that jumper will overheat the driver's regulator and permanently destroy the board. Always double-check your voltage limits before powering on the circuit.
I will see the connection. There are 6 wires from motor driver. I will connect here from 2, 2, 3, 4, 5, 6, 7. Here are written in Arduino Uno. 2, 3, 4, 5, 6, 7. There is an input. These 4 are inputs. 2, 2, 2, 3, 4, 5, 4, 5, and these are 6, 7. 6. Now I will take the ultrasonic sensor and I will connect trigger and echo on 8 and 9. Trigger is yellow. For 8, echo, there is a number 8 and 9. Give a 8 and echo, trigger for a 9. And there is a one ground, means give for a ground. Here it is, they are both ground, give for ground. And there is a VCC, means 5 volt or 3.3 volt. I will give 5 volt. Now there is a motor driver connection to Arduino Uno. There is a ground, to ground, and VCC means 5 volt to Vin. Now connection is done, and I taken a double tape for a ultrasonic sensor. Now see the demo. This is jack. I said it before only. Now there is no obstacles. Now there is obstacles. It stops. This is how to build a Arduino sensor obstacle stopping vehicle.